Today on How It's Made. Custom knee braces. Ductless air conditioners. Window film. And motorcycle exhaust systems. If you suffer from osteoarthritis of the knee, your doctor might prescribe a knee brace. Osteoarthritis is when the cartilage cushioning the knee joint wears out, causing bone to painfully rub on bone. A brace relieves some of that pain by realigning the leg to shift weight off the knee joint. This dual-action knee brace rotates the foot, which moves the thigh bone, the femur, off the most painful area of the shin bone, the tibia. It also creates what's called a distraction, pulling the femur and tibia slightly apart to further reduce stress on the joint. The brace is custom-made for each patient. An orthotist takes the measurements by passing a sophisticated 3D scanner approximately 12 inches above and below the knee. The scanner translates the data into a 3D computer image with highly specialized medical device software. Then processes that image into anatomical blueprints for a 3D model. The computer then reads the plans and guides this carving machine to create the model from a block of high-density foam. The carving process takes about 10 minutes. The finished model is an exact replica of the patient's leg, which technicians now use to construct a brace that fits the patient perfectly. After wrapping the model in plastic film to protect the surface and marking the main anatomical landmarks of the knee, they lay a thick foam band over the tibia and begin marking where they'll install the two articulation hinges, which rotate the foot and distract the femur and tibia. This template is for the lateral hinge, the primary rotator. It's situated on the outside of the leg. Next, taking an aluminum bar and bending it on special tools, the technicians form the brace's tibial crossbar, the band that crosses the shin and holds the two hinges. The foam band takes up the space of a silicone lining that'll go under the tibial crossbar, critical cushioning to prevent pressure points that can cause skin irritation. Once the crossbar fits perfectly, they reapply the template and mark where rivets will attach the lateral hinge. Then, using the same metal bending tools they used to shape the crossbar, they contour the hinge to follow the shape of the leg. They attach the lateral hinge to the tibial crossbar with copper rivets. Copper is a soft metal, so they can compact it to produce a solid joint, which won't loosen up over time with repeated use. At the other end of the crossbar, they affix the medial hinge, which produces the distraction. When the knee is extended, this hinge lengthens the brace by approximately 3/4 of an inch, pulling the tibia and femur slightly apart to eliminate pain. It's time to mold the plastic shell, the upper part of the brace that fits onto the thigh. First, they soften a foam sheet in a low-temperature oven and wrap it around the model. This takes up the space of the fabric lining that'll go under the plastic. After covering the foam in a cotton heat barrier, they soften a plastic sheet in the oven, wrap it around the model, staple the ends together, then coat the surface in talc, which prevents their gloves from sticking when they apply pressure. Once the plastic cools, they trace the shell shape and cut it out. Then they wrap it in a protective vinyl finish, heating the material so that it becomes sticky and adheres to the plastic. They also wrap the tibial crossbar in vinyl. Then they apply a strip of Velcro to the underside where they'll later adhere padding. They install a cover over each hinge to protect the mechanism. Then they cut a fabric lining for the upper part of the brace. It adheres to the plastic with Velcro so that it's removable for washing. or for replacement when worn out. The brace applies the greatest amount of pressure at the tibial crossbar, so they line the crossbar with silicone padding for comfort. The pad attaches to the Velcro strip. The brace fastens to the leg with 3 adjustable straps and works only when the knee is extended, which is when osteoarthritic pain hits the most. The ductless air conditioner, invented in Japan in the 1970s, transforms homes into cool spaces. This system consists of an outside condenser and refrigerant lines that run to a fan in the wall. In homes without ductwork, it provides cooling without renovations. No central air? Ductless air conditioners, also known as mini splits, are a cool option. To manufacture the condenser, they start with copper tubing. It will be used to make the coils that cool and condense the refrigerant. A machine unwinds 6 reels of tubing simultaneously and pulls them between rollers. They iron out the kinks. Little rotating knives cut the tubing to the correct length. The cut tubes exit into a device that bends them around a mandrel. This creates hairpin bends in the center of each tube, and they end up looking like big copper bobby pins. Next, a sheet of aluminum feeds into a progressive die. A press moves up and down to drive the metal into the die. With each stroke, the aluminum is shaped into a part known as a fin. They'll use 100 or more fins in one air conditioner coil. The fins fall out of the press into neat stacks. A worker slides metal rods into the stacks to maintain the alignment of the fins and adds a steel end plate. She now inserts the hairpin copper tubing, following a precise pattern. The fins will act as a kind of web for the tubes. They're an important part of the coil, allowing heat from the refrigerant gas to be dissipated more quickly. Next, a press drives mandrels into the tubes, expanding them so they'll fit tighter to the fins. The coil has really taken shape. At the next station, they load it into a hydraulic bending machine. It bends one section of the coil around a metal form. This gives the coil a more curved profile on one side, so it will fit in the condensing unit later. They close the open ends of the copper tubes with U-bend connectors. They braze the connectors to the tubes for a leak-proof fit. This ductless air conditioner coil is now complete. They're ready to test it for leaks. A technician pumps compressed air into the unit to simulate refrigerant. By using compressed air, they're playing it safe because unlike refrigerant, it won't damage the environment if there actually is a leak. Once the coil is full of compressed air, he immerses the part in water. Air bubbling out would indicate a leak that needs fixing. A worker keeps a close watch on each coil as it floats by for signs of trouble. They're now ready to assemble the entire condenser. The team screws the compressor to the base. They install the coil and attach a motor and fans to cool the refrigerant. The next part is the filter dryer. It contains chemicals to remove moisture and filter out contaminants. They install the wiring and control panel for the compressor and fan motor. The team connects a pump to the coil to suction out air and create a vacuum inside. creating a perfect environment for the refrigerant gas. He closes the service valves and sends the ductless air conditioning unit down the production line to be charged with refrigerant. After that, all that's left is the packaging and the installation. On a hot day, all the consumer needs to do is grab the remote control and activate the ductless air conditioner for some cool air. Developed in the 1960s, window film is a product with transparent benefits. Applied to the windows of vehicles and buildings, this tinted film lets light in while shutting out some of the sun's harmful rays. And depending on the darkness of the tint, it also provides a measure of privacy. Tinted window film allows drivers to see things in a different light, one that can be a lot less harsh. Not only does the tinting mean less squinting, it also reduces the amount of heat that permeates the vehicle's cabin. This film will also hold glass together if it shatters. Because dark tints can make it hard for the driver to see the road or to be seen, the use of window film is regulated in many jurisdictions. The laws vary depending on the region, so the factory makes different window films for different markets and applications. There are numerous formulations for the tinted coatings. It all starts with the acrylic adhesive that will hold the layers of plastic film together. The adhesive will also serve as the base for the tint and other additives. The technician thins the adhesive with solvent, which will make it easier to blend in the other ingredients. Those ingredients include chemicals to absorb ultraviolet rays, initiators to make the mix cure faster, and finally the colorant. It's carbon-based, and as a result, it's highly soluble and disperses well. Achieving the right shade of colorant is truly an exact science, one that started beforehand in the lab. A technician mixed up test batches, combining one or more dyes with the adhesive base until satisfied with the results. Once the adhesive has been mixed, they add a chemical catalyst to activate it. They're now ready for the plastic film. There are various grades and thicknesses. The type used depends on the type of window film being manufactured. The plastic film unwinds over rollers into the coating machine. At the same time, the tinted adhesive flows into a pan in the machine. A roller soaks up the adhesive and applies it to the plastic. The coated film travels over a narrow cylinder with fine grooves etched into it, and the excess formulation collects in the grooves and drips back into the tank. This gets rid of the excess and ensures an even application. The film then moves through a long dryer, and the heat causes the coating to cure. The film exits under a glare of blue UV light. The light activates the initiator chemicals in the adhesive to further cure the coating. Next, a second plastic film unwinds and meets up with the coated one. They travel between rollers that apply heat and pressure to laminate the two films together. A computerized system checks for defects, and a worker does a double check as the film passes in front of a bright light. After a third film, mounting adhesive and release liner have been applied to the product. A technician tests a sample. She pulls it off a piece of glass, and a sensor measures the amount of force it takes. The test confirms the window film grips the glass adequately. The production run gets the green light. So next, blades trim the sides and cut it to width. The width of the film can be customized to the job. At the end of the cutting line, a worker slides a plastic core onto a cylinder. sticks the end of the window film onto that core. He activates the cylinder and it revolves to wind the film up onto the core. Sold in rolls, the film will later be cut for an exact fit to various windows by an installer. Window film comes in a range of colors with a variety of characteristics. The choice is up to the customer. But no matter what, window film is sure to change one's view of things. Motorcycle racers typically replace their bike's standard exhaust system with a high-performance one which emits exhaust gases faster, clearing the way for new fuel and air to enter the engine's combustion chamber, generating more power and better traction, which produces greater speed on the racetrack. This high-performance aftermarket exhaust system isn't any louder than your standard exhaust system, yet it delivers up to 30% more power due to its more efficient design. Rather than steel construction, it's made primarily of titanium, which is more durable and weighs half as much. The exhaust system has two main components: the muffler, which dampens sound, and the header, which routes exhaust gases from the engine to the muffler. The header's tubing is made from a super thin strip of titanium that's 6 inches wide. It enters a forming machine, in which 14 stations of rollers apply tons of pressure to progressively curve the edge of the strip upward until they meet at the top. The formed tube, 2 inches in diameter, then enters a chamber. Inside, a welder heats the top until the edges fuse together into a solid seam. After the 330-yard-long tube exits the welding chamber, a powerful carbide guillotine blade chops it into several shorter tubes. Then workers mount each of those shorter tubes onto a computer-guided machine which bends it to the shape required for several exhaust systems. Workers then separate each system's tubing with a circular saw. Like the guillotine before, the saw has a carbide blade. An ordinary steel blade isn't hard enough to saw through titanium. A welder assembles the tubes to the other header components, among them the collar and flange, which connect the header to the engine, and the bulbous resonance chamber, also made of titanium. It does a pre-muffler sound dampening. Once the parts are welded and inspected, the header is finished. They begin assembling the muffler by joining the two halves of its resonance chamber. The parts must fit with a tight seal to prevent exhaust gases from leaking out. They set the resonance chamber on a welding fixture, take a ring made of perforated titanium, and weld it to the chamber opening. This ring allows a specific amount of gases to enter the resonance chamber at a time. Next, they weld a sound absorption tube to the resonance chamber. They wrap the sound absorption tube in a fiberglass blanket. The muffler's housing is made of a titanium sheet which a machine shapes into a canister. At each edge, they peel back the film, protecting the surface from scratches. Then, with an automated welder, join the edges with a strong seam. Then, they remove the protective film entirely and electrically charge the canister in a mild chemical solution for about a minute. This anodizing, as it's called, changes the color of the titanium and hardens the surface, making it more durable. After attaching an aluminum mounting bracket to the canister, they insert the sound absorption tube. Then secure the canister to the resonance chamber with screws. They apply the manufacturer's sticker, and the muffler portion of the exhaust system is finished. To install the exhaust system, you bolt the header to the motor, which is toward the front of the motorcycle. Then mount the muffler to the other end of the header. The muffler bolts to the bike chassis via a bracket on the canister. Now, the bike is ready to hit the racetrack. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.